I've developed a custom web search agent similar to Perplexity that is capable of running 100% locally with Ollama, or even running with most Hugging Face open source large language models. This is the first in a series of videos where I'll be putting the custom agent to the test. I'll be running a series of parallel tests on questions that I've crafted, and then measuring the performance of each model on this matrix. In today's video, I'll be testing Llama 3 8 billion against Perplexity itself. So stay tuned to the end to see how well the small local model does against Perplexity. I've linked to the repository containing the custom agent code in the description to this video. So if you're interested in that, you may wish to check it out. If you like this content, give the video a thumbs up. Remember to subscribe to this channel. And in the comment section, let me know which models you would like me to test next. Okay, let's get started with the testing. I'll quickly talk through how I'm going to be conducting this test. I've come up with 7 questions, ranging from least difficult at the bottom here to most difficult at the top. For each question the agent gets right, I will be allocating points based on this scoring system. At the end of the questions, I will tally the points and put it against the matrix that I showed you earlier. I'll keep track of that matrix across all the series of videos I'll be doing on these tests so that we can compare across all the different models on how well they've performed on these questions. Hopefully this should be fun, so let's get into the testing. So I'm going to begin testing this custom agent alongside Perplexity. Just to show you in the Python script for this agent, I have set the model that we're going to use behind the agent to Llama 3 instruct. And obviously this is the Ollama version of Llama 3 instruct, which runs locally on the Ollama server. If you want more details about how to get up and running with this agent script and Ollama, I have a video on that and I'll link it in the description for this video. So check that out if you want to get into a deep dive on how to actually set this whole thing up and how this script works. I will also be setting the output to verbose, which means you're going to see all of the websites that we visit to pull information from when we're doing the web search, and you're going to see that returned to the PowerShell where I run this script. I'll do that for the first question to show you how the agent works, but for subsequent questions, I won't be producing that verbose output. So I'm going to set that to false so that the output is a lot cleaner. Okay. So I have my PowerShell open. So I'll start the agent, Python agent.py run. And it's asking me to enter the query. So bear in mind that obviously the agent is going to be slower than Perplexity. I'm not measuring this on latency because the agent is obviously running on my CPU, which is going to be a lot slower than Perplexity, who have probably got a host of GPUs in the background to make theirs super quick. So we'll start off by asking Perplexity. So the first question is actually, when did the capital of Nigeria change? So I expect Perplexity to be able to get this. So we have an answer and we have sources provided, and that is in the true nature of Perplexity. So it says the capital of Nigeria officially changed from Lagos to Abuja on December the 12th, 1991. And we have some sources. So I trust this is probably right. I'm not going to go into those sources for Perplexity. Now I'm going to ask the same question to my custom agent. And this is running locally on the Llama 3 8 billion model instruct. When did the capital of Nigeria change? Just so you can see that, I'm asking the same question. When did the capital of Nigeria change? And it will take some time to run. And remember, this is running on my CPU. At a minute, I'm recording this and I'm also running web browser. So it will be slower than usual if I was just running this Ollama without doing anything else. So we've started the agent chain and we've returned a response from the planning agent. So the planning agent is the first agent in the agent chain, and that comes up with the queries that we should ask the search engine to find the information. So we have the main search identified as capital of Nigeria, and we're putting that into the search engine. So that's the job of the planning agent. And as I said, if you want more detail on how this works under the hood, please refer to my videos, which will be linked in the description to this video. Okay, so we're really getting going now. We've returned the search engine results page. We've picked out one of the URLs from that search engine results page. Let's see. So it's the top one there, Wiki Abuja. And we've pulled some information from the wiki. Okay, so we've returned a response, and that response is from the integration agent. For those of you that aren't aware about how this works, there's a planning agent which comes up with the search engine queries and then uses that information within a search engine to pull a search engine results page. Then we decide which URL is the best to follow to actually answer the query. Then the information from that URL is scraped and passed into an integration agent who synthesizes a response. If the response is if the information pulled from the URL is adequate, we'll provide a final response. If not, the integration agent will go back and provide some feedback to the planning agent that will adjust its query on that basis. So we have a final response delivered, and we've got a final response. So based on the provided research, here is a comprehensive response to query. The capital of Nigeria changed from Lagos to Abuja in 1991. Abuja was chosen as the new capital due to several reasons, including the need for a more central location and concerns about the vulnerability of Lagos to natural disasters such as earthquakes. Okay, and then we've provided some citations. Although I'm not sure if these citations are actually correct because we didn't visit any of these websites. So you can see this. For example, it says HTTPS example.com/Nigeria/capital history. So it hasn't actually pulled the correct citations. So although the response to the question was correct, I'm going to mark this as a fail because it didn't pull the citations. And that's one of my criteria for actually getting this, for actually passing a question. It also has to pull the correct citation in which the information was referenced. So that's a fail for the Llama 3 8 billion model. And it's a pass for Perplexity. So Perplexity gets 1 point and Llama gets 0 points for that first round. Okay, so now for round 2, we're gonna ask our second question. And we'll start off by asking Perplexity. We will ask the question, what is the current population of New York City? So I've abbreviated it here to NYC. Let's ask Perplexity, and I'm pretty sure it's gonna get this right. And what's cool about Perplexity here is it's actually provided a bunch of graphs and analysis as well. Obviously, this local custom agent that I've developed won't do the graphs and analysis, but we're just looking for a right answer. So what has Perplexity said? So it says, according to the most recent data from the US Census Bureau and World Population Review, the current population of New York City in 2024 is estimated to be around 7.9 million people. And we've got 2 sources provided. So we have Fox 5NY, which says roughly how many people live in New York. Let's just have a look at what that source is. So it says 7.931 or 7.9 million people. So let's have a look. What did we say? Yep, around 7.9 million people. So I'm going to mark that down as a pass for Perplexity, and that's going to be 2 points for Perplexity. Okay, next we're going to do the same thing. We're going to test it with the Llama 3 8 billion model that I have locally on my custom agent. So let's see how we do there. So I'll restart the agent by running python agent.py run. And then I'll enter the query, which is what is the current population of NYC? So remember, I've removed the verbose setting. So I've set that to false, which means that we're not going to return all of the output from the scraping the web and the search engine results page and stuff. But you've seen how it works in the first example. So let's keep it neat and we'll go and ask the question. Bear in mind, when you're watching this on video, I have cut this so it's not working at real time. It's not working at real speed. There have been edits made to this to reduce dead time in the video. Okay, so we've stepped into the agent workflow. So the planning agent has come up with a plan to find the current population of NYC. I'll generate some search queries for you. Here are a few. Current population of NYC seems sensible to me. And we're putting that into a search query. So remember, we're not going to generate the scraped output of the website this time around. Okay, so it's had trouble retrieving some content from the internet, but it's going to retry. So that's part of the retry mechanism that I've actually implemented in this custom agent. This scraper for this custom agent is quite rudimentary. So some websites, it fails to scrape the content. because of the formatting or nature of that content. So it will retry another website. Okay, so the integration agent has provided a response. This is based on the research provided. Here's a comprehensive response to your query. So as of the latest available data, estimated population of New York City, NYC, is approximately 8.4 million people. This number has been steadily increasing over the years due to factors such as urbanization, migration, and economic growth. And we have a source provided here. And notice there's no URL provided with this source, which is obviously worrying. We know that we visited the New York Wikipedia site, but no URL has been provided. So that is obviously a concern. Let's see what the final response is. So then we check the response quality and it's passed our quality check, which arguably shouldn't have passed, but let's go ahead. And then we have the final response, which is just what was regurgitated last time by the integration agent. I'm going to mark that down as a fail. What we actually needed was the URL source. And unfortunately, it's not provided that. So that is a second fail in a row for the Llama 3 8 billion model. It's not looking good, but let's continue with the questions and let's see how the model performs on some of the later rounds of questions. Right, so we're on our third round of questions, and Perplexity right now is up 3-0 compared to our custom agent powered by Llama 3 Instruct. But you never know. Let's continue going and let's see what else the custom agent can do. And hopefully we can start getting some correct answers from the custom agent. So the next question is, who won the Premier League 2023-2024 season? So the reason I'm asking this question is because the season has just finished last week at the time of recording this video. So it's definitely not going to be in any of the models training data unless there's an update to the models that I'm unaware of, but I'm sure it's not going to be in any of these models training data. Let's run it on Perplexity first and get the response, and then we'll test it on the custom agent. We have a response from Perplexity, and the answer is Manchester City, which I know to be the correct answer. For those of you that are my American viewers, the Premier League is the main football league here in the UK. It's the top division. So Manchester City were the winners, and they won that last week. And we have some sources here. Let's accept the cookies. So this source actually, right, here we go. So this doesn't actually state who won. It just says Manchester City are back on top. Let's see if there's anything that mentions a win. No, so this source, I believe, doesn't actually mention who won. Let's have a look at the other one that's provided. There we go. So this source provides the winner of the title for the 2023-2024 season. That is another pass for Perplexity. Let's move on to the custom agent with Llama. And I'll once again restart it. I'll enter my query. Who won the Premier League 2023 to 2024 season? I'll kickstart the agent chain. Okay, we've entered the agent chain. The planning agent has come up with a query. So this is the Premier League 2023-2024 winners. These are all search queries that it believes are the right queries to search in the search engine. What's worrying here is we haven't even come up with a search query. And I know this happens sometimes when the planning agent, the planning agent passes the query to a another agent, which is in charge of actually generating a JSON from that agent based on the search query from the planning agent. And what's happened here is the agent that's in charge of generating that JSON hasn't generated that JSON properly. And that's why we're getting a blank JSON response. That's actually not a bug with the code, but that's a hallucination from the Llama 3 8 billion model. So I'm going to mark that as a fail. So Perplexity is now up 6-0. Let's move on to the fourth and see if we can actually get a good response from the custom Llama 3 8 billion model. We're on to the fourth round of questions. And this time we're going to ask our first multi-hop question. So the question we're going to ask is, what is the birthplace of the loser of the boxing match between Tyson Fury and Usyk? So first you have to know the loser of that boxing match, and then you have to know that person's birthplace. And again, the reason I'm asking this question is because the boxing match happened recently. It just happened last week. So I know that the models that I'm using aren't trained on this data yet. So we'll start off by asking Perplexity. So it's correctly identified that Tyson Fury was the loser of the boxing match against Alexander Usyk. And it's also identified that Fury was born in Wythenshawe area of Manchester, England, which is correct. Let's just visit the source, which is Wikipedia. And do we have a birthplace identified here? Here we go. So Tyson Luke Fury was born in Wythenshawe. So that is correct. And Perplexity has managed to easily handle that multi-hop question. So that is another win for Perplexity on that question. Let's see how the agent performs. So again, this is still the Llama 3 agent. So I'm going to run Python agent.py run. And the question is, what is the birthplace of the loser of the boxing match between Tyson Fury and Usyk? Right, let's just make sure I've typed that in right. What is the birthplace of the loser of the boxing match between Tyson Fury and Usyk? Okay, let's run that and see what the agent can do. So the planning agent has come up with some queries. The first one is Tyson Fury versus Alexander Usyk. So that's a good start. Alexander Usyk's birthplace, Tyson Fury's opponent, Usyk's birthplace, Usyk versus Fury loser birthplace. So those are the queries it's come up with. And it's identified the single most important search is likely Alexander Usyk's birthplace. So that's incorrect. It's actually funny to watch this because you can see the limitations of the Llama 3 8 billion model in reasoning already. That is completely false. I'm not sure that it should be asking that as a single most important question. But anyhow, it's done that. So that's been put into the search engine, and we visited the Wikipedia site for Alexander Usyk. And those of you know that had watched the boxing match know that Usyk was actually the winner of that boxing match. So the model has jumped straight to searching for the winner's birthplace rather than the loser's birthplace, who is Tyson Fury. So that is already not looking too good. So we have a response from the integration agent. And what it's saying is, based on my previous research, I found the fight between Tyson Fury and Alexander Usyk did not take place. So I wonder what it means by previous research. Is this stuff that is already in the knowledge base? And I would imagine it is, because I know that the negotiations for the fight were ongoing by the time Llama 3 came out. So maybe that's in the training data. The article only mentioned negotiations and potential opponents, but no actual fight took place. However, if you're asking about the birthplace of Usyk, according to my knowledge, Alexander Usyk was born in, what does that say? Simferopol, Ukrainian SSR, now Ukraine. Right, so that's the wrong answer, and we've returned the final response. So this response quality assessment is just basically checking that we return citations and return the response we return is relevant. And if it passes all of these criteria, we pass and we return the final response. If it doesn't, it's recycled until it does pass the criteria or until we run out of iterations. Now, yes, this shows the reasoning fail for Llama 3 8 billion, because not only have we not identified the loser of the fight, which is Tyson Fury, but we've gone straight to the winner and found their birthplace and also not included any sources. So that is another loss for Llama 3 8 billion. And at this stage, we are looking at 10-0 for Perplexity against Llama 3. Okay, we're on to the fifth question, and we'll start again by asking Perplexity. The fifth question is, find me the cheapest flights to Barcelona from London for one adult leaving next month. Now, look, I'm aware that it is probably not going to find the cheapest flights, but what I'm testing here is the ability for the model to recognize time. By the way, the agent in the prompting does have access to today's date and time, and also just to return some flights to the correct destination with the correct departure airport and the correct arrival airport. So that's what I'm looking for here. And obviously the the source of information should be returned too. So let's try it with Perplexity first, and then we'll move on to the agent. So we've returned some results here from Perplexity. And you can see we have identified the cheapest flights here. So it says the cheapest flight is a one-way flight on Vueling for just £31, departing on the 25th of June, so June the 25th. And that's from cheapflights.co.uk. So let's visit cheapflights.co.uk. And the date is correct here. So we've got London to Barcelona, so that's correct. We have Saturday the 25th, departing from London. Can we find that flight? And there we go. We have a flight for £31. So this is what's come up on this search. So I will actually take that as a pass for Perplexity. Let's see what the agent can do. So I'm not expecting much, but you never know. These models do have the ability to surprise me from time to time. So let's give it a try. Let's start the agent. Find me the cheapest flights to Barcelona from London for one adult leaving next month. Right, let's go. Let's see what we can do. Yeah, and as I said, I'm not holding out much hope for this. So the planning agent has come up with a plan. Says I can help you with that very enthusiastically. Here are some search queries I've come up with. London to Barcelona, flights in June. This search query looks for general flight options for London to Barcelona for next month, giving us an idea of overall prices. So what is good is it's identified June as being next month, which is good because that is showing some time awareness, which is what we want. Cheapest one-way flights from London to Barcelona. By targeting one-way flights, we can find more affordable options compared to round-trip tickets. Budget airlines from London to Barcelona in June. This search focuses on budget-friendly carriers like EasyJet, Ryanair, Vueling, which might offer cheaper fares. So the most important question is London to Barcelona, one-way flights under £200. So that is presumptuous. That is presumptuous because we're talking under £200. Shouldn't it have just gone London to Barcelona flights in June or something like cheap flights? But I guess, it's not the end of the world. So this specific search query targets the cheapest options available for a one-way ticket from London to Barcelona with a price cap of 200. Yes. Okay, fine. Makes sense from the integration agent. So I've noticed we are having some problems pulling that data from kayak.com, and that is more a bug with the custom agent rather than a bug with the model. And the reason being is because it's not actually able to get that text from the kayak.com website. So it says failed to retrieve content due to garbled text, which means there's a difficulty for the scraper that I've coded to actually scrape that information from kayak.com. It is a rudimentary scraper. So I believe it's trying a different website. So these are all the failed sites. So it's trying different pages. Let's hope that we can pull one. There is a retry limit on here, so hopefully we don't exceed that retry limit. Let's see what does happen. So we have a response from the integration agent. And what we're seeing here is, I'd be happy to help you with that. Based on the research provided, I'll generate a response using the information available. The research provides a dictionary of content sourced from Google, which seems to be an introduction to Google services and privacy policy. Unfortunately, this research doesn't contain any specific information about flights or prices. Given lack of relevant research, I'll suggest adjusting the plan to search for more targeted information. Here are some revised search queries. Cheap flights from London to Barcelona, June. This search looks for general flight options from London to Barcelona for next month, giving us an idea of overall prices. One-way flights from London to Barcelona, under 200. By targeting one-way flights and setting a price cap, we can find more affordable options. So what this is doing is it's giving feedback to the planning agent because we're not able to scrape those URLs, we haven't been able to answer the question. And therefore, the integration agent is prompted to give feedback in that case. Well, in the case that there is not, the information is missing from the URL source that it's tried, the integration agent's prompted to give feedback to the planning agent to adjust its plan so it can find different sources from the internet. So I will say this, that is more of a bug with the custom agent that I built, especially the scraper part, because the scraper part does struggle to scrape particular types of content from the internet. So there's probably some work I could do on improving the scraper. But what is good about the agent is that it is entering that feedback loop again. And those sites that I did find difficult to scrape, it shouldn't actually revisit if the prompting is working as it should. So hopefully we can get back in and find just any website that we're able to scrape information from that actually has that has the flights there. So the response quality assessment has been false, and the reason given is the response does not provide a direct answer to the query, instead suggesting revised search queries and offering general observations. While it provides some useful tips, it does not meet the requirements of providing the cheapest flights to Barcelona from London for one adult leaving next month, which is correct. So we're back into the planning agent, and the planning agent has come up with a new plan. And what's worrying here is the planning agent seems to have just regurgitated what the integration agent has said earlier. So those two things look quite similar. That's what the integration agent said. And this is what the planning agent is saying. It's like a regurgitation. And we have come up with a new search query, one-way flights from London to Barcelona under 200, which is exactly the same one that we initially came up with. So that is actually concerning. And we've got here failed to retrieve content due to garbled text. So I have a feeling we're going to be stuck in this loop for a while. I'll see where this lands up. I'll see if we do manage to select another website. has gone back to kayak.com, but it should not have gone back to kayak.com because that's one of the sites it's already visited. So that's under, it should be under failed sites. Maybe not, maybe it starts again from the beginning. Yeah. So I have a feeling we're not going to be able to get to the answer like this. So I'll let it run until the integration agent comes back with something. And if we do manage to get to an answer, that's going to be great, but I'm not holding my breath for that. Yeah, so this is back to where we came from, although we are trying Skyscanner, and I don't think we tried Skyscanner last time. We have a response from the integration agent, and we're stuck in this feedback loop again because it hasn't managed to pull any information from those websites. So I'm going to put an end to the Ollama server, and I'll mark this one down as a fail for Ollama. And I'll be honest with you, I'll be surprised if any of the models I'll test in other videos will be able to get this flights one. And that's just due to the clumsy way in which I built the scraper. But I have a feeling some of the more capable models will be able to iterate through faster and eventually find a website where they can pull information from. So let's see what happens. I'll leave the question on there. It's a tricky one. But that is another fail for the Llama 3 8 billion instruct model. So as we enter the penultimate round of question, the Llama model is losing to Perplexity at a score of 15 points to Perplexity versus 0 to Llama. Now, I'm still holding out hope that Llama can surprise us and do something. So let's move on to the next question, which is another multi-hop question. And this time we've got 4 hops in this question. So the question is, how many Germans live in a colonial holding in Aruba's continent that was governed by Cristiano Ronaldo's country? So it's multi-hop because, first of all, you need to know Aruba's continent, which is South America. Then you need to know Cristiano Ronaldo's country or birthplace, which will technically class as Portugal. And then Portugal's colonial holdings in South America, which is Brazil. And then you need to know how many Germans live in Brazil. So this is complex. We'll start off with Perplexity, and then we'll move on to using the custom agent with Llama 3 8 billion instruct, and let's see what we can do. So let's start off with Perplexity. So we have our result from Perplexity, and it looks like Perplexity wasn't actually able to give us an answer. So what it says is country situated in south of the Caribbean Sea. In the south of the Caribbean Sea, apologies. So we've got some information about its geography, and then Perplexity returns this response. There is no information provided in the search results about Germans living in a colonial holding in Aruba's continent, the Americas, that was governed by Portugal, Cristiano Ronaldo's country. The research results, or the search results, focus on the history of Aruba as a Dutch colony and its relationship with the Netherlands, as well as some of the information about German colonial activities in Africa. There is no mention of Portugal governing Aruba or any German colonial presence there. So you can see Perplexity's kind of misunderstood the question, because the question isn't really asking about Portuguese colonizing Aruba, which is what's kind of implied here. So there's no mention of Portugal governing Aruba or any German colonial presence there. So it's not even asking about German colonial presence. It's asking about Germans living in the colonial holding of Portugal in Aruba's continent. I know that's a bit of a tongue twister, but there is a difference there. So I think that's a fail from Perplexity on that question. So that's the first question that Perplexity's failed. Let's try with the custom agent. And I'm not holding out any hope for the custom agent to work here, but we're going to give it a try anyway. If it does get into that loop again, I'm just going to end it. I'm not going to let it carry on just for brevity. So how many Germans live in the colonial holding in Aruba's continent that was governed by Ronaldo's country? I know the grammar is not perfect on this question, but it should still, when I say it should, I mean an agent or a more powerful agent should still be able to unpick what we're trying to find out here. By the way, this question is a slight adaptation on a question that I pulled from a multi-hop question answering paper. So in that paper, it asks about Prezeres's country instead of Cristiano Ronaldo's country. I just changed that up. So I'll link to the paper in the description to this video as well if anyone's interested in looking at that. Okay, so the planning agent has come back with a response, and it says, I think there may be some confusion here. Aruba is a small island nation in the Southern Caribbean Sea, and it is not part of any continental landmass. It's actually one of the 4 constituent countries that make up the Kingdom of the Netherlands, along with the Netherlands, Caracau, and Saint Martin. Cristiano Ronaldo is a Portuguese footballer, and Portugal is a country located in Western Europe. It has never governed Aruba or any other part of the Caribbean. As for your question about Germans living in Aruba, according to Central Bureau of Statistics, Aruba, as of 2020, there are approximately 1,400 people with German nationality residing in on the island. So it has, I'm not going to continue to read all of that because it's kind of going down the wrong path, but it has come up with some search queries. Here are some search queries I came up with based on your question. Number of Germans in Aruba. So obviously we're trying to find out the number of Germans in Aruba, which is the wrong path to go down here. And then Aruba's demographics. So these are sensible questions. These are sensible search queries, by the way, but it's the wrong path. And I wonder, it's weird because none of these, both Perplexity, I guess Perplexity did identify Aruba as part of the Americas, but Llama 3 has not identified Aruba's continent. So maybe it's the way the question is worded. I am willing to kind of accept that. Even when I read the paper that question was from, it was worded in a weird way. So I can understand that, but it's worded like that on purpose to make it difficult to answer. And that's why it's like that. It's a multi-hop question that's been artificially formulated from single hop questions. That's the whole idea behind the paper. It is in the description, so if you do want to read it yourself, go ahead. And, you know, I've clearly broken this because the integration agent is literally just parroting what the planning agent is doing. So this is clearly not working. And we have actually gotten our final response from the integration agent. And that, unfortunately, is a 0 for Llama 2. So that is the first tied round, actually. So Llama and Perplexity didn't manage to get to the answer here. All right, let's move on to the final question, and then we will calibrate the models against my matrix. I am on to the final question of this series of questions. We'll start off with Perplexity as always. So the question is, what is the current weather forecast in the largest city north of the city where the team that finished second in the 2023-2024 Premier League season played its last match? So this is a multi-hop question, and it also requires current information that the model hasn't been trained on because, as I mentioned previously, the 2023-2024 Premier League season just finished last week at the time of recording this video. So first, you need to know the team that finished second in the 2023-2024 Premier League season, which is Arsenal. And then you need to know where Arsenal played their last match, which was in London. And then you need to know the largest city north of London, which is Birmingham. And then you need to get the current weather for Birmingham. So there's a time awareness bit there too. So let's ask Perplexity. There we go. So it says, unfortunately, the given search results do not provide any information about the weather forecasts or locations of Premier League teams' final matches. The results focus on prediction for 2023-2024 Premier League season, top scorers, financial details of Premier League clubs, and information about the Premier League's youth development program, without specific details about the team that finished second and the city where they played their last match. I cannot determine the largest city north of the location to provide a weather forecast. So I think Perplexity does struggle with multi-hop questions after a certain number of hops. And we don't have a 3-hop question in here. We only have 4-hop questions. So probably at 4 hops, it struggles because the last question was also a 4-hop question. So that's interesting in itself. This is the free version of Perplexity, by the way. So the paid version is probably using a more powerful model and, we'll probably be able to get it right, or the pro version. So this is the free version. So bear that in mind. Okay. So let's try the same thing with our custom agent. I'm going to start up the agent, Python agent.py run. And then I'm going to enter the query. So this is a wordy one. What is the current weather forecast in the largest city north of the city where the team that finished second in the 2023-2024 Premier League season played its last match? All right, let's go ahead. Okay, the planning agent has started doing its thing. So let's see what it's saying. So to generate searches for this query, I'll need to break it down into smaller parts. Hey, that's good. That's a good start. Let's see what smaller parts. What is the largest city north of? Largest cities north of specific location, e.g. London. Cities near location and their sizes. Where the team that finished second in the 2023-2024 Premier League season played its last match. So this is actually quite good. That is one of the questions that we need to answer. So location where team name played their last match in 2023-2024 Premier League season. Stadiums used by team name during the 2023-2024 Premier League. The single most important question might be largest cities north of Manchester and their weather forecast. Now, yeah, so this is where the reasoning breaks down. It hasn't actually been able to identify the most important question, because I would have said the most important question is to find out where the team that finished second in the 2023-2024 Premier League season played its last match. And arguably that could be broken down into smaller questions too. So yeah, that's kind of where the logic fails there. So we have nonetheless entered a search query, and the search query is largest cities north of Manchester and their weather forecast. So then we are visiting this site. I think that says wonderground.com/weather forecast leads. So we're going in the complete wrong direction here, actually. But nonetheless, we have returned a weather forecast, even though it's completely the wrong one. Because we should be, if we're answering this question correctly, we should be getting the weather for Birmingham, not Leeds. And that's because of the reasoning fail here. But hey, the agent has managed to progress through to something. And arguably, this is more incorrect than Perplexity's response, because At least Perplexity said it couldn't give us the answer, whereas this is giving us an answer that isn't correct. We'll check to see if this is a hallucinated source, but I want to see what the data, I want to see what the quality assurance agent says before I do those checks. So let's see. We've got a final response. So based on the research provided, I can see that the team that finished second in the 2023-2024 Premier League season is Manchester City. That's wrong. That's completely wrong. And they play their home matches at the Etihad Stadium in Manchester. The largest city north of Manchester is Leeds. So according to the weather forecast from Weather Underground, there we go. The current weather forecast for Leeds, England, United Kingdom is 73 degrees Fahrenheit and conditions are cloudy. So we have provided the source. I want to go into the source. Let's just have a look. Amazing. So it is a real source, but there we go. It's hallucinated because that link is linking me to the weather for San Francisco, not Leeds. So that is a complete hallucination. Okay, so we've gotten to the end of our parallel testing where we tested Perplexity against my custom agent powered by Llama 8 billion. And if we recall all of the questions here, we know that Llama 8 billion unfortunately didn't get anything right. So that is a 0 in terms of points tally for Llama 8 billion. For Perplexity, we got question 1, 2, 3, 4, and 5 correct. And we didn't get question 6 and 7 correct. So if we tally the points, we should have 15 points for Perplexity. So this is where it puts us on the matrix. So Llama 3 is right at the bottom here at the F tier. That's no slight on the model itself. It's just the performance of the model being used in my custom web search agent. And Perplexity, which is obviously not being used in my custom web search agent, but it's being used as a benchmark, in this case, is at tier B. Now, Ollama is an excellent tool, and it really has democratized access to large language models because you can run them locally. But for agent purposes, I find that you are limited by your hardware. It's painfully slow to run Ollama models on your CPU if you don't have access to a GPU. For agent purposes, you're only probably going to have access to the smaller Ollama models. If you try anything bigger than 8 billion, if your laptop has any specs like mine, and you're just running on your CPU and you try a model larger than an 8 billion size model, it's going to be incredibly slow. And you'll probably lose patience waiting for it to generate anything. And I think the 8 billion model is just too small to be useful in any agent framework. And if it is going to be useful in an agent framework, it's probably having to do a tiny job, something like, I don't know, text completion or something really small. But for the most part, I don't think it's going to be useful in an agent framework, especially if that framework requires agents to perform complex activities. Now, I am going to be doing another video, and that video is going to be testing Llama 3's bigger brother, which is obviously the 70 billion model. So I'll be testing that model. And for that, I'm going to be renting a GPU from RunPod, and I'll be hosting my own inference server on RunPod, and I'll be using that to test the model. So that will be faster. And I anticipate that using the Llama 70 billion model is going to return much better results than using the 8 billion model. And it might even come close to the performance of Perplexity. So if you're interested in seeing that, definitely check out my next video that's coming up. If you enjoy this content, give us a thumbs up. Remember to subscribe to the channel. And in the comment section, let me know if there's any more models that you would like me to test. Thanks for tuning in again, and I'll see you on the next video.